Level 0. Out in the open Pacific, where the water holds more heat than your oven and the air sits heavy with moisture, something begins to stir. A few innocent thunderstorms bump into each other, merge, stretch, spin. The winds are disorganized, but there's movement. Pressure drops slightly. A new circulation tightens like a muscle. This is the moment a tropical depression is born. Winds are below 39 miles per hour, not even strong enough to cancel school, but satellite eyes are already watching it. Because from here, things can escalate fast. In 2009, what started as a weak tropical depression near the Philippines evolved into Typhoon Morakot. Most people barely noticed the early warnings, but Morakot became Taiwan's deadliest storm in 50 years, dumping over 100 inches of rain, triggering massive landslides, and killing more than 600 people. All from a system that began looking like nothing more than a slightly aggressive rain cloud. That's the trap of a tropical depression. It doesn't look violent. It doesn't sound dangerous. It crawls along slowly, like it has nowhere to be. But inside, the engine is warming up. The ocean is feeding it. And if conditions are right, high humidity, low wind shear, and enough warm water, it doesn't stay weak for long. This is the incubation stage of a killer. It's not even called a typhoon yet, but the spiral has begun. Because once those winds hit 39 miles per hour, the storm gets a name. A real one. It earns a designation from the Joint Typhoon Warning Center. From that point forward, it's no longer ignored. It's tracked, watched, analyzed, and in the worst cases, feared. Level 1. At 74 miles per hour, the storm earns its new title. It is no longer a tropical storm. It is now a typhoon. The difference is more than a name. The structure has matured, the eye has formed, and the rotation is now sharp, focused, and gathering speed, like a skater pulling into a spin. The engine is running hot. The ocean is fueling it nonstop. A Category 1 storm is still considered minimal by disaster standards, but that word can be dangerously misleading. It does not feel minimal when you are inside it. Wind at this speed strips leaves off trees and clumps, flattens backyard fences, and rips flimsy roofs apart like wet paper. Power lines come down, entire neighborhoods go dark. In July 2012, Typhoon Vicente hit Hong Kong as a Category 1 storm. It was not expected to intensify quickly, but within a few hours, it did. The city was caught off guard. The Hong Kong Observatory issued a T10 signal, their highest typhoon warning for the first time in over a decade. Winds battered the skyscrapers, sending debris flying through narrow streets. Over 130 people were injured. Hundreds of trees fell. The financial center of one of the world's largest cities was frozen in place by what was technically the weakest kind of typhoon on the scale. That is the real danger of Level 1. People underestimate it. Businesses stay open too long. Residents choose to ride it out. But it only takes one shift in the wind, one snap of a power pole, one shattered window for the storm to turn. Category 1 is not a headline grabber. It is not cinematic on satellite. But it is where disasters often begin, quietly, while people are still trying to act normal. And if the sea stays warm and the upper atmosphere stays calm, the storm will not stay here for long. Next is Level 2. Stronger winds, sharper edges, and the moment you stop asking if it's serious and start asking if you waited too long. Level 2. Now the wind is pushing between 96 and 110 miles per hour, strong enough to snap trees in half, strong enough to take the roof off a poorly built house. This is the level where the storm stops being annoying and starts being dangerous. It is no longer just a loud night and a canceled flight. It is the beginning of structural failure. At Category 2, the winds sound different. They don't just howl, they scream in pulses. You hear things hitting your walls and you do not know what they are. A part of someone else's house, a garbage can, a chair, a satellite dish. Everything becomes a projectile. In September 2014, Typhoon Kalmegi crossed the Philippines before striking southern China and Vietnam as a Category 2. It wasn't a record breaker. It wasn't even in the news for long. But it still killed over 28 people, knocked out power for tens of thousands, and caused nearly $500 million in damage. In Hong Kong, trees blocked roadways. In Hainan, the airport shut down. In the Philippines, the damage stretched across rice fields and coastal towns. This is where the storm feels personal. Power goes out. The air gets hot and humid. The rain hits sideways. One cracked window turns into 5 gallons of water on your floor. Water stains your ceiling. The gutters rip off. Someone's dog is loose and barking until it suddenly stops. Most people stay home during a Category 2. It still feels survivable. But inside the storm, that confidence erodes because you can hear it strengthening. You can feel the pressure dropping. Even the animals get quiet. This is the level where you learn what your house is made of. You learn how much you depend on electricity. You learn what 100-mile-per-hour wind actually means when it is not a number on a screen, but something trying to push your windows in. And if conditions keep feeding the storm, you will not have long to find out how much worse it can get. Because level 3 is next, the point where typhoons are no longer just major storms. They become defining events. Level 3. At 111 miles per hour, the storm crosses into Category 3. The word major is now officially attached, but that word does not quite capture what this means on the ground. These winds are strong enough to rip the roof off a reinforced concrete house, not just damage it, remove it entirely. Walls buckle. Trees are no longer just falling, they're crashing through buildings. This is where the storm becomes a force of transformation. Roads become rivers. Power is not just out, it is out for days or weeks. Cell towers fall, hospitals switch to generators if they can. In many areas, emergency services stop operating. They shelter just like everyone else. Because at this point, no one is coming to help you until the storm has passed. In 2010, Typhoon Meggy struck Luzon in the northern Philippines as a high-end Category 3. The winds reached 140 miles per hour. Meggy destroyed over 100,000 homes, killed dozens, and flattened entire stretches of farmland. It was so massive it stretched across the entire island. The eye alone was over 55 miles wide. From space, it looked perfect. From the ground, it looked like the end of the world. Inside the eye, some people walked outside. It felt like peace. Blue skies overhead, birds flying, quiet. For about 20 minutes. Then the backside of the storm hit, harder than before, reversing the wind direction and catching anyone unprotected out in the open. For many, that was the moment they realized what kind of storm they were really inside. Category 3 is where the scale starts to feel like an understatement. A storm of this size does not just damage infrastructure, it tests the entire system. Power grids, communication, agriculture, flood defenses, everything. And if the water remains warm and the atmosphere does not intervene, the storm will not stop here. It will keep tightening, keep deepening, and it will push past the point where even strong cities start to break. Level 4 is next, and at that point, the word survivable stops being a guarantee. Level 4. At this level, the wind is no longer measured in terms of speed. It is measured by what it can take away from you. With sustained winds between 130 and 156 miles per hour, a Category 4 typhoon doesn't just damage structures, it dismantles them. Well-built homes lose roofs entirely. Some buildings begin to collapse under the sheer force. Entire sections of cities go dark and do not come back for weeks. The sound of the storm is deafening, not like thunder or a passing train, but like metal screaming. Wind tears through alleyways, lifts vehicles off the ground, and tosses objects the size of furniture. Anything not tied down becomes airborne. Storm surges flood coastlines, power grids fail, communication networks collapse, and when it is over, the damage is measured in billions. In December 2021, Typhoon Rai, locally known as Odette, made landfall in the Philippines as a Category 4. It hit fast, intensified faster, and struck with terrifying precision. Over 400 people were killed. Homes were flattened. Aid workers described entire communities as wiped off the map. Concrete buildings crumbled. Airports were shut down. Roads vanished under landslides. Relief took days to arrive, and in some remote areas, help did not come for over a week. A Category 4 typhoon does not just interrupt life, it resets it. People who survive often return to find their homes gone and their streets unrecognizable. In some places, even the coastline has moved. The wind cuts through towns like a giant saw, and the flooding finishes what the gusts do not destroy. By now, staying behind is no longer just a bad decision. It is a gamble with odds growing worse by the hour. Shelters flood. Emergency response is stretched thin. Hospitals operate under crisis conditions or shut down completely. And if the storm tightens just a little more, if the core pressure drops just a few more millibars, something changes, something final. Because level 5 is not just stronger, it is something else entirely. Level 5. Over 157 miles per hour, that is the threshold. But most Category 5 typhoons do not stop there. They keep climbing, tightening, intensifying until they become something else entirely. The wind no longer just destroys buildings, it erases them. Well-built homes are leveled. Concrete structures fracture. Entire city blocks are ripped apart. The air pressure in the storm's core is so low it crushes the atmosphere inward. The wind roars like a turbine. The ocean is pulled into the sky. Storm surges reach 2 or even 3 stories tall, swallowing coastlines and pushing miles inland. Even high ground may not be safe. Flooding comes not just from the sea, but from the sky as rainfall turns every slope into a torrent of mud and debris. In 2013, the world witnessed what this looked like. Typhoon Haiyan, known locally as Yolanda, made landfall in the Philippines with sustained winds near 195 miles per hour. It was one of the strongest tropical cyclones ever recorded at landfall. Coastal cities like Tacloban were annihilated. Entire neighborhoods were flattened in minutes. Bodies were found in trees. Shipping vessels the size of apartment buildings were thrown inland and stranded in the streets. More than 6,000 people died. Millions were displaced. The storm hit so hard that local infrastructure ceased to function entirely. For days, there was no help. Only silence, wreckage, and the rising stench of mass death. Category 5 storms are rare. They are the final level of the Saffir-Simpson scale. But nature does not build to meet our systems. It builds until it runs out of fuel. And the ocean is only getting warmer. Every year we see storms creeping closer to the top of the scale, and when they cross it, we have no official words left to describe them, because there is one more storm science says is possible. A theoretical one. A storm we have never seen but absolutely could. It is not just stronger than Category 5, it exists on a different scale entirely. Next is Level 6, the Hypercane, and if it ever forms, it will not be remembered as a storm. It will be remembered as an event. Level 6. Category 5 is the highest rating on the Saffir-Simpson scale. But it is not the ceiling of what nature can create. There is something beyond it. A theoretical storm so violent, so powerful, that it would not just break records. It would break the planet's systems. This is the Hypercane. First proposed by Dr. Carey Emanuel at MIT, a hypercane is not fiction. It is physics. The ingredients are extreme, but plausible. You would need ocean temperatures above 48 degrees Celsius. That is 118 degrees Fahrenheit. Something like a massive underwater volcanic eruption, a supervolcanic event, or an asteroid impact could trigger it. Even long-term climate change, if left unchecked, could edge the sea closer to the danger zone. Once formed, a hypercane could have sustained winds of over 500 miles per hour. That is fast enough to strip the bark from trees, erase infrastructure, and toss buildings like playing cards. The eye could stretch 30 miles across. The cloud towers would punch into the stratosphere, rising more than 20 miles high. That is so tall it could inject moisture into the upper atmosphere and damage the ozone layer. Not just a weather disaster, a planetary one. And it would not just hit one coastline. Simulations suggest it could last for weeks, long enough to circle the tropics, long enough to strike multiple continents. There are no evacuation plans for this, no storm shutters, no reinforced shelters. A hypercane would erase any place it touched. You do not survive this kind of storm. You avoid it, or you are gone. We have never seen one, but we know it is possible. And the more the oceans warm, the closer we move toward the edge of that possibility. Not every catastrophe starts with fire. Some begin with water, heat, and the silence before a spiral. So the question is no longer just how strong storms can get. The question is what happens if we live long enough to meet the one that ends the scale? Would we even be ready to watch it form? Or would we only understand what it was once it had already arrived?